Okay, next week is all messed up. I don't know if you've heard or not. We got wacky schedules. Some periods are 60 minutes, some are 30, some are 70. They're just kind of all over the place. So here's what I need for you to do. We have an agenda. We have a week's worth of work that we're going to get through next week. But it's going to be different for every class because you'll need 60 minutes and the fourth period's only 30 minutes. But by the end of the week, we'll all be caught up and done. So what I need you to do is I've posted the assignments as though we had just a regular week. So you need to get on Schoology this weekend and write down all the assignments or whatever you do, just so you know, this is the bulk of stuff that's going to be due. Some of it is review, because we're going to have a test next week. Your test is going to be on Thursday, over the first half of the chapter. So all the review homework is due on Thursday. Everything else will be due the following Monday, okay? So get on there and get all of that stuff, get kind of organized, because you're going to be responsible for all that stuff, but not necessarily on the day that I have it posted. Okay. All right? Okay. All right, we've got a few things we need to get through, and then we'll look at some homework questions. First, however, I want you to find in your packet, there is something called Precal A Period 5 Quiz 1.2 to 1.3. Looks like this. I always forget to number these pages. It would be so much easier if I numbered them. Yes, it's in there. It's in your BFF packet for this section. It's about halfway through, so that's it. All right, let's go through this together. And we're also going to discuss the back side because that's some more symmetry information that we need to touch base on. Yeah.
I never got that packet. I remember thinking that when we were going over this. I just
Okay,
did my notes.
they're in the bottom right, or bottom left, I mean, bottom left thing over there. Okay, so here we go. We are going to answer a whole bunch of questions about this equation. I'm going to add to the list. Not only are we going to do vertical asymptotes, horizontal asymptotes, and holes, but we're also going to do x-intercept and y-intercept. I'm adding that to the list because you need to be able to do all of that. All right, so who has an idea about anything of this or where we might start? Hannah?
Vertical asymptote is x equals 2.
Is what?
X equals 2.
Okay, it's horizontal. The horizontal asymptote comes from this right here. That's y equals, and look, Hannah, here's how you remember. Y equals 2x squared over x squared, which means y equals 2. So your horizontal asymptote is y equals 2. You are not responsible for graphing this at this point, but just so you get a visual, I'm going to go ahead and sketch it. So there's my horizontal asymptote at y equals 2. All right, and Vincent, did you have an idea?
Yeah, you can factor.
Absolutely. We're going to factor everything. So if I take a 2 out of the top, I'll have 2 times x minus 3 plus 1. And on the bottom, what do I have on the bottom? X minus 3, x plus 3. Now what do you notice? The minute you get it factored, you notice something.
2x minus 3.
You can cancel the x minus 3's, and your problem then reduces to this. Now, what does the fact that you canceled something mean? You have a hole. And your hole is an ordered pair. It's a point. And the x-coordinate of the hole will be 3. I saw your seat was empty, so I marked you absent, but it's Jasmine that's absent. That's not your fault. Pay more attention. Okay. Now, again, the hole is a point. I need a y coordinate. How am I going to get a y coordinate? Plug 3 in right here. X is 3. If you know x, you just plug it in to find y. So 2 times 4 over 6 is 8/6 or 4/3. So I have an open circle in my graph at 3, 4/3. A hole. All right. What else? More ideas? We got a bunch more blanks to fill in. Bailey?
The vertical asymptote would be x equals 3,
X equals -3. There's only one vertical asymptote, and it's x equals -3. Now, where do vertical asymptotes come from, gang? Denominator equals 0. In the beginning, you may have thought there were going to be 2 vertical asymptotes, right? But what happened? One of them got canceled out. It's called a removable discontinuity. So there's only one vertical asymptote, and it's at x equals -3. Again, you're not responsible for the graph. I just want you to kind of see what's happening here.
So if you had like x plus or 3 and x plus 1 on the denominator, would you have 2? So it'd be 3 or -3, -1.
Yep. Yep. That's entirely possible.
How do we solve for vertical asymptote?
Wait, how did you get in here? When did you get here? You just walked in?
A couple minutes ago.
Where have you been?
Mass.
Okay.
How do we solve for vertical asymptote?
Where the denominator equals 0.
Okay, so you solve for x.
Yeah. What makes the denominator 0? Just think of what number would make the denominator 0. Okay, speaking of zeros, we are looking for x-intercepts and y-intercepts. Now, just remember, kids, if you are at any point on the y-axis, like that one right there, what can you tell me about that point? What do you know about him? X is 0. So for my y-intercept, I'm going to let x be 0. So if I come back to my equation, and I let x be 0, y will equal what if I let x be 0? 2/3. So my y-intercept is the point 2/3. Again, you don't have to graph, I just am so that you can see how all the pieces fit together. Now, similarly, if I'm on the x-axis, anywhere on the x-axis, what can you tell me about this point? Y is 0. So now I'm going to let y be 0. And for some reason we struggle with this. We absolutely shouldn't. This is so easy. You want to multiply this over to here. What's going to happen when you bring this over here? It's still 0. Solve that. What makes that equal to 0? So solve that. Just it's a little equation. Just solve it. What do you get? -1. Now, I know because I've done a zillion of these in my life that this picture would look like this. You might recognize that as a version of what? Reciprocal function. Looking at the equation, that kind of makes sense because the reciprocal is the only one of our BFFs that's a fraction, right? And this is a fraction. You don't have to graph it. Although really you could if you knew all that stuff. All right, anybody have a question about that before I erase it? Robert?
So do you, to find like everything else, you just plug it into the equation?
Mm-hmm.
Could you do that for everything
What do you
besides the horizontal asymptote?
I'm not quite sure I know what you mean. Everything comes from the equation, yes.
Okay.
But to find all these points, one coordinate is known. So like this 3 was known because it's what we canceled. The zeros are known because they're intercepts, and so one of the coordinates is going to be 0.
Mm-hmm.
So if that's what you mean, yes. If you know one coordinate, you just plug it in and find the other one every time.
Okay.
The horizontal asymptote comes from this, and the vertical asymptote comes from whatever makes the denominator 0. All right, what about number 2? What's the domain? X is greater than or equal to 2. We know that because whatever is under the radical has to be bigger than or equal to 0. And when you solve that, it says x is bigger than or equal to 2. Now that should make perfectly good sense to you now, because that's a square root, right? There's your square root function. What does that minus 2 do to your square root function? 2 units to the right. So now you have that shape 2 units to the right. Do you see how the domain is bigger than or equal to 2? There's nothing over here. That's empty space. Right? All right, now we got some graphs. List all the graphs that are even. Okay, what does even mean again? Symmetric across the y-axis. So which ones of the pictures shown have symmetry across the y-axis? A and B. Which graph is absolute value? B. Which basic graph is D? Use words or an equation. That's a cubing function. And what impact does the 2 have in the equation x minus 2 squared? 2 to the right. 2 to the right. All right, turn it over. There are 4 symmetries that we are concerned with. At this point, we have only discussed 2 of them. We've discussed what makes curves even and what makes curves odd. So those 2 symmetries we've talked about. What's even again? Across the y-axis, which means if you change the sign on x, y doesn't change, y stays the same. And then odd means symmetry across the origin, which means if you change the sign on x, then you also change the sign on y. Right? So those 2 we've already talked about. There's also symmetry across the x-axis. For example, it wouldn't be a function, but could you have a picture that looked like that? Yeah, and that would have symmetry across the x-axis. And then we also have symmetry across the identity line. So let's look at our reciprocal function since we just talked about it. Now that guy has other symmetries too, but if I folded my paper on that line, do you see how it's balanced? So we're going to talk today about symmetry across the x-axis and symmetry across the identity line, y equals x. All right, so here we go. Number 1, we're just going to do this. Number 1, we got the equation 2x squared and we want to know if it has symmetry across the x-axis, y-axis, origin, and y equals x. Now, these 2 you already know how to do. Anybody remember how we do it algebraically? I know you could do it from a picture, but do you know how we do it algebraically? Bailey, do you remember?
I was just going to plug in.
Okay, what number were you going to plug in?
0 and 1.
Okay, Never ever use 0 and 1. They are too special. Weird things happen with zeros and ones. So pick some random number.
4.
4. All right, what are you gonna? So you're gonna plug in 4. Okay, so if I plug in 4, I get 32. All right, now what? We're doing y-axis.
Yeah. I wasn't quite sure what to do next.
Plug in -4. And if it's even, Victoria, what has to happen?
It has to equal 32.
It has to equal 32. So if I put in -4, this is my equation. If I put in -4, do I get 32? So this is definitely an even function. It has y-axis symmetry. Remember, if you are symmetric about the y-axis, if you put in 4 and get 32, then if you put in -4, you also get 32. Right? Same thing on both sides. Now, can we do the same thing with the origin? Yes. We can put in 4 and get 32. And if we put in -4, we also get 32. That shows me we're not symmetric about the origin, because what has to happen when you want symmetry about the origin? You have to have a negative there, right? Both sides. Think about going from here to here. If this is plus plus, doesn't this have to be minus minus? And it's not. This is plus plus, but this is not minus minus. So there's no symmetry about the origin. Now let's do we can do the same thing. Let's do x-axis. All right. Now think about what that means. Now if we're doing x-axis, we need to go from here to here. So you plugged in 4 and got 32. Right? Now, I also need to be able to plug in 4. This is not a function, so this is a little bit tricky. I also need to be able to plug in 4. If this is 4, 32, what would this be? Yeah. Is that going to happen? When I plug in 4, am I ever going to get -32? No, so I don't have x-axis symmetry either. Can we think of an equation where that might happen? Where we plug in the same number, but we get 2 y values for it.
What is y squared?
Yeah, what if we had x equals y squared?
Yeah.
Now, if I plug in 4 for x, I could get what? Either 2 or -2? So that one would have x-axis symmetry. Do you understand that? Now this one's a little bit tougher. What this one means, I'd like you to look at a couple points on this graph. This, let's say, is the point 1, 2, and this is the point 2, 1. So let's look at the equation, y equals 1 over x, so you can see how this works. If I let x be 2, what's y? 1/2. Now, what if I let x be 1/2? Y is 2. If you have this kind of symmetry, what happens to your ordered pairs? They switch. They switch. So if this has that kind of symmetry, when you plug in 4 and get 32, then you should be able to plug in 32 and get 4. Does that happen here? Not even close. So it doesn't have that symmetry either. If you are symmetric across the identity line, it means your ordered pairs have switched. All right, let's look at the next one. let's just make a note over here. We can use whatever numbers we want. For x-axis symmetry, think about x-axis now. If we put in 4, we should get 2 or -2, right? That's what happens if you're x-axis symmetry. What about if you're y-axis symmetry? Put in 4, get 2. Put in -4, get 2. What happens with the origin? Put in 4, get 2, then put in -4 and get -2. Put in 4, get 2, then put in 2, get 4. Now, I don't have that memorized. I don't want you to memorize that. I want you to use this picture right here. If you have symmetry, start with any point. I started with 4, 2. Start with any point you want. If we have symmetry across the x-axis, what does this point have to be? 4, -2, right? If we have symmetry across the y-axis, what does this have to be? -4, 2. Across the origin, -4, -2. And then across the identity, that one you kind of just do have to remember, it means the ordered pairs are switched. So which of those relationships happens with this equation? Pick a number, let's put 2 in. When I put 2 in, what do I get? 7? When I put -2 in, what do I get? 1. Okay, now you can stop right there. What kind of symmetry do I know I don't have? I don't have y-axis. Can you tell you're not going to have x-axis? Because you can't get a -7 out of this, right? When you put 2 in, you can't get -7. I can't tell if this is making sense to you or not. How about the origin? If I put in 7, do I get 2? If I put in 2, I got 7. If I put in 7, do I get 2? No, so we don't have that. Or that's not the origin, that's the identity. That didn't work because I already tried that and it didn't work. So we're done. There's no symmetry. This one has none. Which makes sense because it looks like this. It's a line. All right, try the last one on your own. See if you can sort the last one out. Oh, all it says is even or odd, but let's test all the symmetries for it. Why do I think it has symmetry about the origin?
Because it's the same thing.
Because when I changed the sign on my input, my output also changed sign. Look, I went from 2, -2 to -2, 2. Isn't that across the origin? Why did I say it has symmetry about the line y equals x? Because the ordered pairs are just switched. So the technique, the answer to the actual question that was asked, is this odd? The answer is yes, because it has symmetry about the origin. So let me say this one more time. If you have symmetry about the origin, that means if you change the sign on your input, the sign on your output also changes. It has nothing to do with the fact these are all tubes. That's irrelevant. It's the signs you look at. So So the sign on the input changed, the sign on the output changed. That means you have symmetry about the origin. And again, when you get confused, just look at your little map. All right, there are two other things we need to talk about today. They're not in your packet, so that this will just be some notes you've got. I want to take a look at one of these functions here. A simple little function like this. And yesterday we talked about composition. Trevor, what are you looking at? Huh? Okay, that's all right, that's good. Yesterday we looked at building compositions. So we looked at taking two little functions and putting them together into a composition. Remember doing that on Friday, on whatever day that was, Wednesday, whatever day it was. Remember doing that? Now, let's do that, let's practice that, because today what we're going to do is undo that. You're going to take this function and write it as a composition of two smaller functions. Okay? So we'll say we're going to write it A, G of X. But let's review this first. Oops. This problem literally says find H of G of X. Right? Okay. So that means I'm going to take G of X and plug it into, this is G of X, I'm going to plug that into H. So I'll have 2, 3x plus 1, or 6x plus 2. Now, does anybody have a question about that? So this function was generated by putting these two together. So now what we're going to do is take this function and figure out what put it together. And it's so simple. You're not going to believe this. It's so simple. If you stuck a number into this function, like 7, you would do two things to it. The first thing you would do is multiply by 2. And the second thing you would do is add 3. So you want to build two functions, one that multiplies by 2 and one that adds 3. The functions that multiply by 2 and add 3 are these. Those are the two functions that you're going to use. This one times this by 2. This one adds 3. Now, which order do we have to have those functions? Because that's important. For this equation, what has to come first? The multiplying by 2 one, right? So when you build this composition, is it A or B that's going to be the multiplying by 2 function? Isn't this where you start? So B is 2x. B is the function that times us by 2. And A is the function that adds 3. If you put these two things together, you will get that. Let's do it just to make sure. A of B of x would mean A of 2x. What would A of 2x be? You take this out. Wouldn't it be 2x plus 3? Easy. Let's do another one. Here's your function. And you're going to build, this time let's do B of A of x. So you want to find two functions, A and B, that give you this. Now again, this is only going to be confusing if you let it. If you stuck a 7 into this problem, two things happen to it. what's the first thing that happens? Subtract 3, right? You would subtract 3. So you need a function that subtracts 3. What's the second thing that happens?
X squared.
It gets squared. So you need a function that squares. Now, what order do those have to happen in? Subtract 3 first. So when I look at this, which function is going to be my subtract 3? A. And B is x squared.
Is it always the one that's inside of the brackets that's first?
All right, now one more. This one has 3. We're going to do 3 on this one. So let's say we have the function. And let's do A of B of C. So we're going to do A of B of C of X. We're going to break this down. So when you look at the function, the big function that you were given, can you see 3 things happening? What's happening? If you stick a 7 in this, what are you going to do to it?
Multiply by 9.
Multiply by 9, so one of your functions is 9x. What else?
Add 1.
Add 1. One of your functions is x plus 1, and one of your functions is x over 9. There are your 3 functions.
X over 3.
Oh, 3. Those are your 3 functions, right? You need to multiply by 9, you need to add 1, you need to divide by 3. Now you just need to do that in the right order. So we have A of B of C. So what's the first thing that has to happen here? Multiply by 9. So which function is that going to be? C of x is going to be 9x. What's B of x going to be? That's the next thing that happens. Add 1, and A of x will be divided by 3. Got it? Okay. One more topic, and then we'll do homework questions. So, last topic for today, take your calculators out and put a standard window. And we are going to graph this. Can anybody tell me a problem with that? We're going to graph this. So what button do you press to put this equation in? Oh, wait a minute. What button did you say that was? Y equals. Not y squared equals, but y equals. So when you got a squared, when you've got anything other than a plain y, you have a problem if you're going to put it in your calculator, right? How are we going to do this, kids? And when you say get y by itself, Reagan, what do you mean I'm going to have to do? Square root it. So y is going to equal 25, the square root of 25 minus x, or negative the square root of 25 minus x. Because when you take the square root of both sides, think about completing the square. When you take the square root of both sides, don't you have to put a plus or minus over here? These are called the implicit functions. So when someone asks you for the implicit functions, don't let the word scare you. It's exactly what Reagan said, solving for y. Now I can put them in. I have to put them in separately.
So we're doing both?
Yep, we put them both in. So we do the square root of 25 minus x and negative square root 25 minus x. And when we hit graph, let me change my window. Let's make x max be 30. so you can see the whole view. What did you get? What shape did you get?
Parabola.
A parabola, but the parabola opens this way? Any ideas why this is kind of a special situation, why we treated this differently, or it was more work than a regular equation was? What is this not? It's not a function. Your calculator is a function machine. It can only graph functions. Is this equation right here a function? This one? Oh, yes, it is. That's the top half of your parabola. This is the top half. If you look at only the top half, is that a function? Yes. What's this? The bottom half. If you look at only the bottom half, it's a function. So that's why your calculator graphs them separately. When you put it all together, it's not a function, but your calculator doesn't realize that. It's graphing them in their implicit form. These are implicit functions. Let's try another one. Your job is to graph this on your calculator. You can't in its current form. So what are we going to do?
Subtract 3x squared.
We're going to solve for y, just like yes. Well, that's right. So if we subtract 3x squared, this time I'm going to have to divide by -1. I'll take the square root. So my implicit functions are this equation and this equation. And I'd like you to write those separately, just to remind yourself that there are two of them. I'm not sure. Does yours have kind of a gap in the middle of it?
Yeah.
I'm not sure. I gotta examine how to get rid of that gap. But here's the idea. I went back, actually I didn't, but I'm going to go back to a standard window. And what I'm getting looks better with a standard window. There's still a little gap, but not too bad. What I'm getting is that. What shape is that? You should notice from last year. What do we call that? Starts with an H. It's a hyperbola. That's a hyperbola. Is it a function? No, absolutely not. That does not pass the vertical line test, does it? It's not a function. But if you graph the top half of it, that's this equation, and the bottom half of it, that's that equation, then they are functions. One more, and then I'm done. Now, anytime you put an absolute value in there, you know what shape you're going to get, right? What shape? You're going to get a V. Problem is, normally, what's inside the absolute value? X. You cannot put this into your calculator. I know you know where the absolute value button is, and that's great, but you can't graph it. You gotta have y equals to graph it. So thoughts about this? I need my implicit functions.
Y by itself.
What?
Y by itself.
Okay, I need to get y by itself, so, oops. All right, so now now I've got the absolute value by itself.
Would you multiply it over or just divide it over?
Divide what over?
Absolute value?
Oh, interesting idea, Robert, never thought about that. Highly illegal, but,
Yeah.
If I said, the absolute value of y equals 3, what could you tell me about this right here? What could this be? It could be 3 or negative 3, right? So whatever this is, it could be plain y, but it also could be negative y. Would you agree with me? So here is one of my implicit functions, just regular, just drop the absolute value essentially. And the other one will be negative x plus 1. Would you agree with that? Okay, so now these are our implicit functions. Let's put those into our calculator. Now we have a little bit of a problem. Did you get a V?
Two V's.
What did you get? Well, 2 V's or an X,
Yeah.
right? Part of that is not right. Part of that is extraneous, and you need to figure out what part's extraneous, and I'll tell you the easiest way to do it. Looks like what I've got is this. Now, absolute value is always a V. Okay, so we either, and when it's y inside the absolute value, it's not a function, so it's got to either be this V or this V. So guess what I'm going to do? I'm going to pick a point like here, and if it works, then it's this V, and if it doesn't work, then it's this V. And when I say works, I'm going to put it back in the original equation. Not these, I'm going to put it in the original. All right, we'll give that a shot. Please do check Schoology. Make sure you're clear on what all of your homework next week is. Because like I said, it's going to be a little bit fragmented. On Monday, we'll be having a quiz. Did we do a practice quiz today? Yes, we did. Emma, can you hit the off? Thank you.